Hello. In this video, I want to show you how to create different roof types for your buildings. Let me maybe show it on an example. So this is something we will be creating. Um, and yeah, this will be fairly simple. So I hope to make this video pretty short, but I will also explain some nice little things you can do with it. And let us jump to the starting file where I have some historical, the historical center of Erfurt with all the buildings from it, and also some generated blocks. And these two sets of geometries we will be using for example of how to create the roofs. Let me maybe briefly show you different types of roofs. You can definitely find more than this, but we will mainly focus on gable roof, this very first item here, and the hip roof. And you can see the difference here is that the gable roof has on two sides it is vertical, so the facade just continues to the roof ridge. Yeah, also we can um, see here some terms about some names of different roof types, like hips of the roofs, which are just the edges of our roof, the ridge, which is the upper edge, gable, which is the this side segment of the roof, and the roof pitch, which is yeah these which are these surfaces here. Um, Let us start with the hip roof because it is the simplest one, and then we will jump to the gable roof. So I'm starting with my Erfurt city center, and first thing I want to do is to trim the full geometry I have with a smaller boundary here, so that I can get nice looking segment of the city. Because of course I don't want to work with the full city when I'm still constructing my script. So I will just name my data containers here. So it's streets and buildings. Very nice. I can now zoom in to these buildings and just work with a small piece of the city. So to um, follow me, you'd need to download a plugin, which is called, let me show it to you, which is called Archi Shop 3D. So you can download it in the package manager, and I remind you to access it. You simply go into the tools in your Rhino settings, in your Rhino menu, package manager, and here you can just type Archi and you will get it here. Then install it, restart Rhino, and let's continue. So when you open this uh, tab of the plugin, you'll see Architectural Elements subtab here. We need to open it and select the model roof component. The model roof component only takes three inputs: the curve of our roofs, the angle in degrees, so it's not radians, it's just proper degrees, and roof segment data. And we will come to this one a bit later. So for now, what we need is just to connect buildings to the curves. And as an angle, we need to create a new slider, maybe from 10 degrees to, let's say, 90. I will connect it here. And yes, if I click on my component, I can see that actually most of the roofs are already generated, and it all looks nice and pretty tidy. So some buildings failed to generate roofs. So I guess like one, two, three, four. It's not that much. And also, if I increase the angle, I hope that some of the buildings get a proper roof now. And so now I only see one building here, one building there, here, here. So still some buildings were not calculated entirely correctly. I cannot tell why it happens because the model roof does not. Oh yeah, well, it actually does give you some insights on what's happening inside. So it tells me that the curve is not closed. And I think this can be applied, like this applies to all of these cut buildings, which were just cut with my region. But these buildings inside the region, I'm not sure they're not closed. I just think it might be some other error. So sometimes it helps to graft your list or maybe flatten it. But yeah, not in this case. Then we can leave it as it is. We can probably manually generate these building roofs for buildings which were not proceeded processed correctly. And also, it's not that many of them, so that's quite fine. One little thing you might want to do with your buildings before you generate roofs for them is to simplify their outlines. Because sometimes, as you can see, buildings look quite simple, but actually, if you zoom in on the roofs and check all of the segments which are visible there, you will see that they can actually consist of much more segments than you would think of. So maybe in some cases you want to get rid of those so that your building roof geometry looks a bit nicer. And to do it, you can apply reduce component. So reduce a polyline by removing least significant vertices. That's exactly what we are looking for. I will just apply it after the trim with region component. So maybe I'll just copy my buildings here and connect it there. Okay, so let us check what happened. If you oops, if you select both of these components and go into the Rhino viewport, you will see the changes. So some buildings were simplified a bit, and yeah, it might help you to generate better results for your roofs. So if you open the roofs, now you will see that still some buildings did not get the proper roof, but some shapes just look nicer. Like I will show an example of this building here. So that's how it looks now. And this is what happens if you disable the reduce component, right? And just connected buildings directly without the reduce component. So this is what changes. Of course, you have to be careful with it because sometimes, especially if you're dealing with already existing buildings, you can destroy some geometry details here. And yeah, so as you can see, I introduced some gaps like this one, and also some of these passages between buildings got too narrow. So you don't always want to reduce your geometry. And if you do it, then you can set the tolerance to be something very low, like let's say 0.1 meter. And I believe the tolerance is given here in meters. And you can also read what this tolerance means. It is the allowed deviation between original and reduction version of the curve. So if I give it 0.1, I hope that I will avoid most of the yeah most of the cases where my reduce introduced some errors, but I will still have pretty nice looking geometry. Okay, so this thing is done. We can play with the angle, and also changing the angle sometimes fixes some roofs. So in many cases, you will just have to maybe manually set different roof angle to some buildings. But yeah, for now, I think I will just leave it as it is. If you apply the same script to generated buildings instead of existing buildings, like let me connect streets to parcels and buildings to buildings. And the bound, I don't care about it. Oh yeah, I cannot do that. So um, yeah, maybe as my bound, I can just select um, the full area of my parcels here. Yeah, okay, this looks nice. I don't need simplification here, but I will still leave it as it is. And let us check the outputs. So these are the results I get. Um, it looks quite nice. I think all of my buildings were um, given some roof, so I don't have any bad shapes here, except for maybe the closed blocks. I am not sure whether I have the closed blocks here. Yes, I think I do. Oh yeah, and this is why trim with region actually failed, because my buildings here was stored as surfaces, and if you try to convert surfaces into curves, you will see that most of them will be converted very easily, but some surfaces, like these closed blocks, will not be converted. It happens because Grasshopper cannot find this unique representation of a surface as a single curve, because for a closed block, like this one, you actually need two curves, right? It's the inner perimeter and the outer. And since Grasshopper cannot find just one curve to represent the surface with, it fails. So if you would ever need to convert your surfaces into curves without like these errors, one way to do it is to use the brep wireframe component. It just takes any surfaces and converts them into edges, into segments. And since you don't usually need segments, but you need the closed curves, you can join the curves. So you just apply join curves after brep wireframe, and here you go. So this is the difference. I got also all of the closed surfaces converted to curves. I can now flatten the output, and I can now try to connect it to the trim with region. So it's just a manual conversion to curves. Um, but I assume that we won't get some nice results here. Let me check it. So yeah, exactly. This is what happens. Because the model roof component does not know that we actually have this closed block typologies. It just takes curves as inputs. So it took the first curve, the outer curve, and it took the second curve, the inner one. And it just generated roof for the outer and roof for the inner curves separately. So this is something you have to deal with, and probably if you want to avoid it, you could somehow subdivide your closed block in two parts without introducing any gaps. You can just maybe trim it, or yeah, I think surface split would be the best component to do it. And later on, you can just think of it as two buildings, which together create this closed block. And yeah, this is how you can avoid this problem. I'm not gonna do it now just because I don't want to spend much time on it. So I will simply connect my original buildings and streets and set the bounds back to my rectangle here. Okay, let us jump to the second typology we want to tackle today. And this typology is the gable roof. So now we have the hip roof. We need to convert it to the gable roof. The difference between them, as you can see, is this front and back facades, which go all the way up to the roof ridge without having any roof slope or roof pitch here. So there is not there doesn't exist a component to create this type of roof. We only have this model roof component. So we will need to improvise a bit, and we will need to find the way how to control the angle of individual roof pitches for this task. And here I will explain you what the third input of model roof means. So it takes roof segment data, and as the description reads, roof segment angles for individual roof segments. So you can specify which angles you want to use for which segments of your roof. To do it, you would need to take another component from the plugin, which is called roof segment data. It is the same name as here, roof seg data. So I put it here, and now I need to somehow understand how to how to specify angles for each individual roof segment. So the roof segment data has two inputs: I, which is the index of the roof segment, and angle of the roof segment. And also um, notice that you don't need to specify angles for all segments because you only need to specify roof segments which should have a different angle than the other segments. So we will still have the default angle, but for some indices of roof segments, you can specify another angle. And that's what we will be using now. Um, okay, so now we somehow need to describe the task for us, right? So what do we actually aim for? What do we want to achieve in the end? And I would probably say that, yes, I want to create the Gable roof typology for all the buildings on my plot. And I want this gable to face the street. So I want my buildings to have vertical facades facing the street. Probably makes the most sense because then the roofs of neighboring buildings will just slope towards each other, and it's good for water management. It's good for ventilation. It's good for sun access into the buildings because you have facades facing the street, and so you get more sun from there inside the buildings. And I want to do this. So for every building, I basically aim to find the segment which is facing the street, or is one single segment which is the closest to the street. And I also want to find the farthest segment from the street because I want to have two gables on both sides of the building, on the front side and on the back side. So I want to find this front and back side segments, and I want to specify another angle for them. So the angle which I want to give them would be 90 degrees. This is something I know already. I want them to be vertical, so I can connect it to the roof segment data already. And now, yeah, let us start with the task. So first of all, for every building, we need to find the closest street, right? Because we need to find out which of the segments are closer to the streets and which of them are further away. So I would use the curve closest point to find the distance between buildings and streets, so that for every single building, I find one closest street. So I want to reduce my buildings to points. So I connect it to the area component to get the centroids of my shapes. And in this way, I can I can now evaluate the distance between each of centers of every building and all the streets. So I can use the curve closest point. I connect streets to the curve input and building centers to the P input. Notice that I have to graft something here because the curve closest point, I need to I don't need to find the distance between the first building and the first street, and then the second building and the second street, and the third building, the third street, and so on. I want to do it differently. I want to find the distance for every building. I want to find all distances to all the streets. So I have 365 buildings and 85 streets. So basically what I need is to have 85 distances, one distance to towards one street for every single building. It means I can graft the P input, and by doing this, I put every center point of my buildings into a separate branch. And now inside the separate branch, I calculate distance to all 85 streets. And the same I do for the second building, the same for the third, and so on. And as the result, I get a data tree with 365 branches by number of buildings, and each of the branch has 85 numbers, 85 distances. I only need to find the shortest distance or the closest street actually. So I sort my list of distances, and so the first element in the sorted list would be the shortest distance. But as I mentioned, I do not need the distance itself. I actually do not care what the distance is. I just need the closest street. So I also want to sort streets together with the distances. So I connect it to the sort list second input. And as you remember, by doing this, I sort streets along with distances. So now the first element in this A output would be the closest street for every single building. So I can use the list item here, connected to the second output of sort list. And now I get a nice list of 365 streets. Okay, this is very nice. So for every building, I now have one closest street. And now I need to jump to the second part, or I think it's the third part already, where I find out which of these segments of each building are the closest to the street and the farthest from the street, and thus find the front facade and the back facade. I can do it by exploding my building geometry. So I explode it into individual segments. Oops. And now I need to measure the distance between each of these segments and the closest street. So I again use the curve closest point. I again want to reduce my segments to just the middle point of each segment. I don't want to evaluate the distance from the whole segment. I just need the distance from the center point of the segment. That's some complexity reduction here. So now for buildings, I have center points of their segments. I connect it to the P input of curve closest point. And as the C input, I need to use these closest streets here. And again, as the result, I get some distances. Yeah, I don't need to graft or flatten anything here because I have the same structure already. It's 365 branches. Each branch has many segments, like 18, 30, 11, 5, 4 segments of every building. And in the second input, it just has one closest street. So it all looks nice. Now I need to sort distances again. And since we don't care about the distance itself, but we do care about the closest segment, I need to connect the segment to the second input of sort list. And I again use the list item here to retrieve the very first element in this list. Okay, so I get some nice looking results. I can try to check it. So I can try to preview my closest edges and also the streets and check whether it all looks plausible. And I think it does. So most of the lines I have here representing the closest segments indeed follow the street network. this is good. And now I need to connect it to the roof segment data somehow. So let's check what it expects to get as the first input. So it expects to get the index of the roof segment, which should have a different angle. But I only have the elements themselves. I don't have the indices. One way to find out what is the index of an element in the original list is to use the um, item index component. So it retrieves the index of a certain item in the list. Exactly what I need. Because I already have the list of my items, right? It's just the list of segments. So these are my segments. I can connect them to the list item, to the item index L input, which is the list. And as the item to search for, I can connect this list item I output. So in this list of segments, I'm looking for this particular segment. You can also check the data tree structure. It's all very nice. So it, of course, will work inside every branch separately without mixing up my data. And if you connect the panel to the output of this item index, you will see that it actually converted my geometry into indices of these segments in the original list of segments. And this is very nice. This is exactly what I need to have. So I can connect it to the roof segment data now, to the index input. And finally, in the end, I get 365 branches, each having one element. That's just the roof segment data. This is, yeah, the element. This is the type of data which the model roof expects to get in the third input. So now be careful because we cannot connect it directly to the model roof just now because it gets a list of 365 buildings, and but our roof segment data component gives us a data tree of 365 branches. So I first need to graft my building outline input of the model roof to put them each in individual branch, so that if I connect my roof segment data, it will like understand which which roof segments I mean, and which buildings it should be applied to. So I have done it now, and let me check the result. So for now, it doesn't look that well. So some buildings indeed got pretty nice flat facades here. It's not buildings, of course, it's only the roofs, but you can create buildings underneath yourself. But some buildings are not looking that good. So sometimes, let me just find some examples. Yeah, sometimes this building, let's say, it got the vertical facade on the left for some reason and not somewhere here. I ran into this problem before, and this is why I had to re-record this video maybe 3 times already. Because now and now I actually found out what was the reason for this behavior. It wasn't that easy, but the solution is pretty simple. This is because the model roof component enumerates all the edges a bit differently than this explode component does. So to make everything work, I will just show you what you should do. You should create some space on your canvas after reduce component. And here we need to flip all our building curves in the same direction. So we need to create a flip curve component, connect our curves to it, and here this is very important. We need to specify some guiding curve for this flip operation, because otherwise flip will just flip all of the curves to the other side. So it basically, what does it mean? I didn't explain it. If we deal with the closed curves, like we do, there are two ways to store them in memory. You can either enumerate points clockwise, or you can do it counterclockwise, right? And this will result in exactly the same geometry, but just, yeah, it's like two different ways of how you can store the order of these points. And we need to make it consistent. We need to make all our um, curves face, yeah, to be stored in the same order. So we need to specify some guide curve. And to do it, I usually tend to create a small rectangle like this and use it as the guide curve here. So that's pretty simple solution. And look what happens to our roofs if I connect it there. So let me zoom into some place where we have weird behavior, like here. We clearly see that the street is to the right of the buildings, but for some reason the chosen edges are on the left. So if I now flip my curve and connect the output of this C to the buildings, you will see that something indeed changes. But you can also see that, yeah, it is still not correct, right? Still, for some reason, now the left part of this building is set to be vertical. Oh yeah, actually, I'm very sorry. I think I chose the wrong example to show it on, because actually, if I disconnect the flip curve again, you will see that there is a hidden passage here under the building. So in this case, this is completely correct, because these are yeah, these segments of the building are of the buildings are um, um, the well, they're facing some street. They do not face the main street, but they do face some street. So in this case, the script behaved correctly. So let me find another example, like maybe this one here. You clearly see that the distance from this edge is much closer to the street than from this edge. So this is where something should happen, and it does not. But you can also see that in all other cases something has happened, and this happens because we need to apply another flip curve. So now all of our curves are flipped, let's say clockwise, but all of them, right? So now all of them follow the same pattern, the same direction. But what we're looking for is the opposite direction. So now we need to flip all of our curves in the opposite direction without specifying any guide. So we do it only once here, but here we don't need to do it. And now if you check the results, you will see that in this case, there is probably another street. Yes, there is another street at the back of this building. So this is why this segment was chosen to be the front facade for some reason. But in other cases, it should get much better. Here we also see that we indeed get the vertical segment facing the street, but it is so small, it is so tiny that yeah, the other roof angles dominate over it. So maybe I can decrease my roof angle. Oh yeah, I'm not sure it actually makes anything better, but yeah, for now we'll leave it as it is. You can see that in most cases, at least, we get pretty nice results. And as I mentioned, I also want the back facade to be vertical. So I need to also create another rule for yeah, for back facades of my buildings. I can do it by duplicating the list item here after the sort list and reversing my list before I retrieve the first element from it. So by doing it, you can see that um, I indeed retrieve the front and also the back side of my building now. I can try to connect it to the item index as the second input. So now the item index would find two indices for both of these elements from the original list of segments, give them to the roof segment data, and this one will give this data to the model roof. Let us check whether it works. So I think it does not. I think it creates some weird results. So maybe I need to, maybe I need to duplicate this roof segment data and item index to handle those two streams of data separately. So I will just do it like this. Okay, and now I connect the second roof segment data here as well. Let us check whether it looks good now, and I think it does. Yes. So you can see probably the roof segment data can only work with one input of the index, and it could not handle two numbers at the same time. So we just have to um, duplicate our pipelines for creating for finding out what is the closest and what is the back facade and the front facade, finding the indices for them, and use two roof segment data components to specify angles for them. And finally, in the end, I get some nice looking results of buildings which have the roof, the Gable roof facing the front side of the building and the back side. And so this is how it looks from the top. And I think it actually looks quite nice already. So at this point, you might want to play a little bit with the tolerance of your reduce component, because now as it is set to 0.1, you can see that still some of my buildings are consisting of many small segments, and so only one of these segments can be selected as the front facade, right? And sometimes it just happens that a very small one is being selected, and so my final geometry does not look very nice and very correct. Let me try to find such cases. Yes, maybe like this building here. Let me show it to you. So this building here indeed does have a vertical face. This is it. But you can see how small it is. So we actually do not even notice it because it is so tiny. And the reason for it is that we have a very small we have a very small edge of our building over there. So, oops. If I, after explosion, I will see that, I cannot even zoom in there, but there is a small, tiny segment of the building which is selected to be the front facade. So sometimes it makes sense to reduce complexity of your buildings. Let me go to reduce, and instead of 0.1, I will maybe enter 1 there. Okay, so you can see we indeed get some better results, if you can say that it's better. So we do get the vertical Gable roof here at this point. But at the same time, you see that it doesn't make that much sense to create this kind of building for this kind of roof for this building. And here I come to the last part of this video. So even though we have solved maybe 90% of this building roof geometries here, and it all looks exactly how we want it to look. We have the Gable facades facing streets and also facing the backyard, but there are still, and there will always be, some cases which we cannot solve with this simple logic, like this building here, which was not generated, like the roof for which was not generated completely, by the way. Um, it just doesn't fit our rules because it is too complex to find out which facade is the front facade, which of them is the back facade, and so on. And in these cases, you will need to do something manually, and you will always have to introduce some manual logic to your scripts and to create some exceptions. And it's not bad or anything, it's just something you have to keep in mind. So in this case, one way to create some exceptions for buildings with different shape would be to calculate the number of segments for my buildings. Yeah, I didn't need to move it to the right actually. So here, where I have my building segments, I can calculate amount of segments for each building, and let's say if the amount of segments is less than 10, I can apply this Gable roof typology. If the amount of segments is more than 10, like in this building here, like in that building here, then we just stick to the heap roof, which works a bit more reliable and generates more plausible forms. So I simply need to check whether my number of elements is in this list is larger than 10. So I use the larger than component and the list length component to retrieve the length of the number of elements. And if so, then I want to use call pattern to just remove this roof segment data outputs, right? So I connect them to the L input of my call pattern, and let me check what I have now. So for now, um, these two um, these two components result in this kind of data. So for every branch, I have exactly two elements. Each of them is a roof segment data element with some index and some angle. But if I apply cal pattern, and the pattern would be this evaluation of number of elements, whether it is larger or smaller than 10, the result will be, okay, so I think I have to invert my pattern. So right click on the pattern, click invert, and yes, now you see that some of my branches are empty, and they're only empty for the buildings which are too complex to apply our simple logic of gabled roofs. And some of them still do contain these two elements. So now if I connect it to the R input of my model roof, you will see that, yeah, some buildings, oh, here something very weird happened. But yeah, all of my complex buildings now do not have the gabled roofs. They just follow the normal typology of the roof. So this building here does not have any vertical facades. This one does, because it is simple and it's like pretty good shape to apply the gable roof. This one is complex, so we don't want to apply any gable roof type to it. Because if we did, let me reconnect it back again, you will see that it can result in some weird shapes. So I want to avoid it. And that's what I do. For some buildings, you can still encounter some weird shapes. And maybe this building here, as you can see, still has the gable roof. Probably because the number of segments is not larger than 10. So you also might want to play with this number and maybe set it to 6. Yes, and now you can see that I get rooftop here. And also this one looks nice now. So it's a matter of how you set up your logic of which coefficients and which tolerances and thresholds you set um, for the filters. And yeah, now you can of course play with these two different angles for the roofs. So the standard one and the one for the gable roofs. You can of course make them just different. They don't have to be vertical. And yeah, you can now apply the same logic to our generated blocks. So I reconnect my streets, parcels, buildings to buildings, and the bounds I need to set another curve for it. And so I get some results already, and this is how it looks like. And for this topology, you would probably need to create other rules for finding out which segments should be considered gable roofs and which of them should be just a normal sloped roofs, simply because we have a lot of these L-shaped buildings, which of course have more than one facade which is facing the street. Yeah, which is facing the street. So in this case, you need to change your logic a bit. But now my logic works quite well with these existing buildings. So I will leave it as it is. And I hope this video was helpful for you. You can experiment with the roofs. You can also experiment with other plugins because there are a couple of them which give you the same functionality but different amount of control over your roof. I personally prefer this one just because it allows me to create a gable roof pretty easily, and other plugins do not do it sometimes, or they are too buggy. Yeah, so I hope it was helpful, and see you in the other videos.